Hey Tense, how you going? This is a continuation of the walkthrough through 6G. So I'm just starting on the second half of question 3, which is where the first video kicked off. So this video is intended for you to be following along with your workbook and doing your own recordings as you go, pausing the video every so often to do your work. And it might even be, I explain through one of them and then you pause and you try the next one and then you unpause and see if you get it right. That's how you learn rather than just kind of blindly copying through it. So anyway, so we'll finish off doing B, D, and F for this question here because I did A, C, E on the last video. So for this one here, we want to draw. Now, if we're drawing from the slope-intercept form, which is y equals mx plus c, what we want to do, I did ABC last time, so I'm doing D, E, F. So what we want to do is we want to just make sure we know what the slope is and the y-intercept. Okay. So the slope is going to be, so I'm working on D at the moment. So the slope is going to be the coefficient of x. So for this one, it's -2. Now what we want to do though is we want to put it as a fraction. So instead of -2, I'm going to say -2 over 1. So if there's a whole number rather than a fraction, it's just over 1. And then the y-intercept is going to be 5. So then how do you draw it? So what you want to do is get your set of axes. And remember, you can draw more than one line on one set of axes. Your y-intercept is where the line is going to cut through this y-axis. So the y-intercept is 5. You just need to look up and down your y-axis kind of vertical line and just get y equals 5, which is right there. And then from there, what you want to do is you want to do rise over run, okay, to get the second point. And then from 2 points, you can draw your graph. So rise is -2 and run is 1. So from this dot here, rise means you go up. However, if rise is negative, that means you go down, okay? Think of it like an elevator. If it's positive, you're going up. If it's negative, you're going down. So the rise of -2 means we're going down 2, and the run of 1 means you're going across 1, okay? Like that. Now the run is always going to be to the right, always. The rise might be negative, which means you go down instead of up, but the run is always going to be this way. So that's my 2 points. So from there, I can just get my ruler and just try and draw a straight line through those dots as best as you can, just like that. And then we'll usually say next to it, we'll just draw the equation, y equals -2x plus 5. So y equals -2x plus 5. Okay. So the next one, so I'm just going to so that was for D. And now over here, it's going to be for E. Just like that. So for E, the slope is going to be -5 because that's the coefficient of x. So the slope is going to be -5. And remember, we're just going to do -5 on 1. And the y-intercept is here, -7. Okay, so that's the slope, the y-intercept. So this one's a bit trickier. So let's grab a different color, grab green. So the y-intercept goes first and it's -7. So we're going to go all the way down here, -5, -6, -7. And then the rise over run is -5 over 1. Now this one's tricky because it's going off of our graph, which is a bit frustrating, okay? So it's going to be going down 5. So we're going to go 1, 2, 3, 4, 5, all the way down to this imaginary -12 point, which is probably not far down enough, but that's me not getting the correct set of axes, and across 1. So it's going to be like all the way down here, okay? Now I'm going to do another point and I'm going to go the opposite. So if it's down 5 across 1, I can also go across 1 the other way and up 5, 2, 3, 4, 5, and then I can get another point like that. So basically from this point, I'm going down 5 across 1, okay? The only reason I've done that is because this is not super accurate based on the grid lines that I had. So if I was doing this in my book, I would extend my grid line. So I've got, it goes down to 12. So anyway, from there, I'll just grab 1, 2, 3, 4, 5. I'll just grab something like that. And that's my line there. So that line is y equals negative 5x take 7. Oops. Y equals negative 5x take 7. Probably shouldn't draw over another line, but that's okay. The last one, y equals negative x take 4. So this one's a bit tricky. So this is f. And that's because this has no number there, negative, and then it's no coefficient. That's an invisible 1, negative 1. So that's going to be negative 1 over 1 as the slope. And then the y-intercept is going to be negative 4. That's the y-intercept. Okay. So I'm looking at negative 4 as my y-intercept. So I'll just grab my orange. So y-intercept of negative 4 is going to cut through the y-axis at negative 4. And then my rise over run, again, is a negative number. This whole thing has been negative numbers. So we know by now a rise going up and down, if it's negative, it means you go down. And it's negative 1. So you're going to go down 1 and across 1. And you could keep doing that if you wanted to. Down 1 across 1, down 1 across 1. And that's going to be the gradient. You don't need to do it that many times, but it just gives you a bit of an idea of what is going on. So then we get our line like that. And that is it. So that is our line of y equals negative x take 4. Good. Sorry. Just want to draw. Just let me draw. Y equals negative x take 4. Awesome. So that is done. That one took a while, but let me just show you very quickly. You can draw any of these on your graphics calculator. So if we go back to the beginning, you can go to the graph mode here. So just navigate your way to graph. Just move my face. And then the functions here are in the form of y equals, and then you put the rest in there. So if I do y equals negative 2x plus 5, I can just put in negative 2x, the x button's up here, x plus 5, and then draw, and we can graph that line. And I can kind of see, so negative 2x plus, oh, what did I do here? Negative 2x plus 5. Yep, okay. So that's my line there of negative 2x plus 5. And that's the line on the graphics calculator. Now, it looks a little bit different in terms of the steepness, but that's just because the axes on the graphics calculator are a bit, see, that one goes to 9 and 11. So it's a bit skewed. It makes the graph look a bit different, but it is correct. And something we can test is we can go shift and we can go G solve up here and we can go y-intercept. Now the y-intercept is 5, which is what we had too. The y-intercept here was 5, okay? So that was for the first one. And then we can also go shift G solve. Actually, I think we'll leave that for this one. So you can see that line's graphed in there. Okay, we'll leave that, we'll move on. All right, so sketch the following lines. Okay, so we're going to sketch the following lines here. So I've crossed out the ones where we're not doing. So y equals 4, y equals negative 2. We'll do those first. So for y equals 4, what we're going to do is we're going to go up to, on the y-axis, so this one here, we're going to go up to y equals, we're going to go up to 4, and we'll draw the line going across there. And that's going to be our answer. So this is y equals 4. And I'll draw just arrows on each end. Now the reason for that is, why does it go this way? Every point on this line is going to have a y coordinate of 4. So this one here, that dot would be x is negative 7 and y is 4. Okay, because we're going negative 7 on the x-axis and we're going 4, 1, 2, 3, 4 on the y-axis. Okay. This point here would be x is negative 1 and y is 4. This one over here would be x is 1, 2, 3, and the y coordinate would be 4. So basically for a line y equals 4, every point on that line, and that could go on for infinity, would always have y equals 4. So based on that logic, let's do y equals negative 2. So if y is 4 here, you would be going down on your y-axis to -2 and just drawing a line there. So that would be y equals -2 because every point on that line would have a y-coordinate of -2. So now that we've done that, let's look at the x-axis. So x is -2. You'd be going the other way. So on your x-coordinate, on your x-coordinate, you'd be going to -1, -2, and you'd be drawing your line just like this. So that would be x is -2. And then your x equals 9 would be all the way over here, 5, 6, 7, 8, 9. And that would be like that. X equals 9. And that would essentially go on forever as well. Okay. So every time you see something like that, that's where it would be either a horizontal line or a vertical line. Okay. And you just need to see if it makes sense, whether it's y or x, based on if every point on that line would have the same y coordinate or the same x coordinate. So now we're going to be writing the equation of these lines. So the gradient of 4 and the y-intercept at 2. So this is basically the opposite of what we did in question 2. Okay. So for 5a, so for all of these, we're going to be going y equals mx plus c, where the coefficient of x is the gradient or the slope, and the c is the y-intercept. So the first one is going to be y is equal to 4x plus 2. Oops, where'd that go? Plus 2. And that's because the gradient of 4 goes there, and the y-intercept of 2 goes there. Okay, and it's plus 2 because it's positive 2. For b, it's going to be y is equal to 3x take 2. So the gradient of 3, or the slope of 3, is why it's 3x. And the y-intercept of -2 is why you put take 2. Okay, you don't go 3x plus -2, it's 3x take 2. For c, gradient of 5, y-intercept at 0. That's an interesting one. So you could go y equals 5x plus 0. Oh, I said 0, but I wrote 8. But then if you think about that, do you have to write plus 0? No, you don't. You can simplify it, 5x. Okay, so that is the more correct answer. Although if you're in a test, if you put plus 0, it probably wouldn't matter too much. For d, the gradient is -3 and the y-intercept is 5. So that's going to be y is equal to -3x. Don't forget the negative sign in there. And then plus 5 for the slope. For e, the gradient of -4 is going to be y is equal to -4x. And then the y-intercept is take 3. So it's going to be take 3. For f, the gradient or the slope is -2. So it's going to be y equals -2x. And then y-intercept at 0. Remember, you can write plus 0, but you don't need to. So we're just going to leave it as y is equal to -2x. Okay, for this one, determine the gradient and the y-intercept for the following lines. And the clue is to use rise over run for the gradient between the two node points. Okay, so I'll just make a quick table to kind of solve this one. Okay, so for this one, you've got some graphs sketched and we need to find the gradient and the y-intercept. So by visual inspection, we can find the y-intercept for all of them. And that's probably a bit easier. So let's just do that first. So for A, the y-intercept, when does this line go through that y-axis? It's in the origin. So the y-intercept is 0. For B, when does this line cut through the y-axis? It's here. And that's at 3. Okay. Now this isn't giving you coordinates, which is the tricky thing. That's just saying 3, which means 3 on the y-axis. So I'm just going to put a 3 there. This one, it cuts through at 4.5 and it's got it marked there, 4.5. So it's going to be 4.5. Or you can say 4.5, but we'll just leave it because it's using a decimal. So we'll just leave it there. This one, it's cutting through here, which is y equals 4. This one, it's cutting through at y equals 7. And F, it's not cutting through at all, okay? So there's no y-intercept, okay? So that one. 0 is probably not the best one thing to say, so we can say undefined. Okay, I've double checked my answers for that one, and instead of undefined, we'll say none. Okay, so not 0, but none, because there is no y-intercept. So now the harder part is probably going to be the gradient. Now remember, the gradient, we want to get 2 points on the graph, and we want to do rise over run. Okay, rise over run. Now, in order to do this, I think the best way is to get the point and write the coordinates. So the coordinates are 0 and 0. Okay, 0 and 0. We looked at coordinates in one of the earlier chapters. Now, for the difference between these two, the rise, okay, so if we say gradient is rise over run, the rise is the difference between the x coordinates, okay? So if we go from 0 to 4, so up, 0 to 4, that's a difference of 4. And then the run going across is looking at the difference in the, I've done it the wrong way around, haven't I? Sorry, I got mixed up. So going up is the y coordinates. So it's 0 to 4, but it's the y coordinates. Sorry, I made that mistake. And then going across, the run is the x coordinate. Okay. So think of the rise as the y coordinate difference, and the run is the x coordinate difference. Okay. So we're going across 4. Okay, so the gradient is 4 over 4. Now, can we simplify 4 over 4? Yes, we can. 1, because that divide both by 4, so it's 1 over 1, which is just 1. Okay, so the answer to that is 1. If you wrote 4 over 4, that's okay, but it's not simplified. So let's look at the next one here. So this one, it's just got 3. Now that 3 is the y-intercept value. But if we were to write a coordinate for that, it would actually be 0, 3. And then over here, it says 2, but that's just the x-axis. So the the x coordinate. So the proper coordinates here would be 2 and 0. So if we do our rise over run here, going from 3 to 0, the difference between that is going to be our rise. And you can kind of see it's a negative slope. So you know it's going to be a negative number. So that's going to be a negative 3. And then the run is going to be the difference from 0 to 2. So going from 0 to 2 is 2. So the gradient for this one is going to be negative 3 over 2. This one here, again, let's do the coordinates. So that's negative 9 on the x-axis. So that's going to be an x of negative 9 and a y of 0. And then this coordinate here is going to be an x of 0 and a y of a y of 4.5, not negative. So if we do rise over run, going from this point here to this point here, and we can see it's positive. We're going up and then we're going across. So the rise is going to be from 0 to 4.5. So that's going to be 4.5. And your run, which is going across, is going to be negative 9 to 0. So the difference there is positive 9. So you're going from negative 9 to 0, which is a difference of positive 9. Okay. So that gradient is going to be 4.5 over 9, which can be simplified to 1 over 2 because they're both divisible by 4.5. This one here, the gradient is going to be 0, and you can just tell that by visual inspection. It's not going up or down, it's just flat. So that has a slope of 0. E has a slope of 0. Finally, some easy ones, some flat ones. If it's a vertical line, the slope is undefined. That's where I got mixed up before. Undefined. It's so steep that you can't say a number. It's so close to infinity that we can't actually give it an actual number associated with it. All right, so this one is matching linear equations to the sketches shown. This one has just got a lot going on here. Which ones can we kind of cancel out really quickly, I think. So I'm just going to use a highlighter here. So the first one I can see is this one, y equals 4. And I can just see this one here because you've got that flat line with a slope of 0, and see it's got the 4 there. So that's a pretty easy one. Same with x equals 2. That's the one that's going to be going vertical. So that's that one there. So it's got the x equals 2. So we can knock out those ones really quickly. The next one, let's have a look here. Basically, I'm just looking for a y-intercept here of 4. So if I'm looking at this first one, y-intercept of 4, and I'm just looking which ones have y-intercept of 4. So there's only this one here and this one here, so B and D. And then I'll look at the slope here. So basically this one here has a slope of, so that's going to be going up 4 and across 2. So it should have a slope of 2. So 4 over 2, which is simplified to 2. So that's this one. So the other y-intercept of 4, which is there, is going to be this one here. And I'll check that. The slope is negative x. So essentially that means it should be going in a negative fashion. So that's another way to tell the difference between these two. That's a positive slope and that's a negative slope. And here the gradient is positive, here the gradient is negative. So I don't need to do much more than that. I don't need to overthink it too much. The y-intercept of 3, let's look for that one. 3 here. Yep, so that's that one. Because you've got the y-intercept of 3. The y-intercept of 6, let's look for that one. Here, yep, that's that one. Let's look for the y-intercept of 2. That's here. Yep. And now these ones here don't have a y-intercept. And let's just see, it's these two here. Yep, so you can see how it goes through 0. So that's why they both don't have a y-intercept. So then let's look at the slope. See, this one has 7. So that means the slope is going to be up 7 across 1. And look here, up 7 across 1. So that one is that one there. And then this one is, the slope is negative 3. So that's going to be, it's going to be down 3 across 1. So that's down 3 across 1. So you can see if that's negative 1, 3, if you went down 3 and across 1, down 3 across 1, you can do that as well. And you can graph any of these lines really easily. Okay, so we can go into our graph function. And we can just delete that. And we can go, let's say y equals negative 3x. Just say, for example, these last two here, you're a bit confused which one's which. Okay, oops, y equals negative 3x. And we can do the other one. Let's just do the one. Let's just do the one. Draw. And you can see it goes like that. So if you're tossing up between this one here and this one here, which one it is, you can look at that shape and you can go, oh yeah, it's negative here, as opposed to this one that's sloping in the other direction. So that's why I know it's that one. Okay. So guys, we're going to leave it there. There's a few more questions, but I think for the most part, we've got a sense of what we're doing. So thanks very much for watching this video. Hopefully you learned something from it, and I'll see you in class.